Welcome to RE07.
In today's lesson,
In today's
we learn
lesson,
how to
we will
size
learn
and
how to
electric
size an
motor
electric motor
system
for conveyor belt
using
system
Python.
using Python.
In modern
In
industry,
modern
conveyor
industry,
belts
conveyor
everywhere
belts are
in
everywhere in
airport,
factories,
warehouse,
airports,
and mining
warehouses,
plant.
and mining plants.
Every conveyor
Every
needs a
conveyor
complete
needs a
size.
properly sized
If
motor.
the motor
If the
is too
motor
big,
is too
it will
small,
fail.
it will fail.
If the motor is too
If the
large,
motor is too
it
large,
wastes
it
energy
wastes
and
energy and
cost.
increases costs.
Traditionally, you
Traditionally,
calculate motor
engineers
sizes
calculate motor size
used for
manually
formula.
using
But
formulas,
today,
but
we
today
do it
we will do it
automatically using
automatically
Python.
using Python.
By the end of
By
this
the end
talk,
of this
you will
lesson,
understand
you will
the
understand
engineering
the
behind
engineering theory
conveyor motor
behind
sizing,
conveyor motor
the
sizing,
key parameters
the key
required to
parameters
design,
required for design,
how formula
how
implemented
formulas are
in Python,
implemented in Python
how
teasers,
Python
how
doing
Python automates
industry
real industrial
reconciliations. Let's
calculations.
begin.
Let's begin. Understanding the conveyor system. A conveyor belt system consists of a belt that carries material, rollers supporting the belt, a drive pulley, a gearbox, an electric motor. The motor rotates the drive pulley. The belt moves and transports the load. To size the motor correctly, we must calculate the total force required to move the belt. Then we calculate the mechanical power required. Finally, we select a motor with suitable power rating. This is exactly what our Python program will do. Key input parameters based on a real beer factory conveyor. In a beverage factory, conveyor belts continuously transport bottles or cans between filling, capping, labeling, and packaging stations. These conveyors are designed for continuous operation, high reliability, and food grade standards. Before designing the motor, engineers collect standard industrial parameters from the production line specification. For a typical beer bottle conveyor, the design input parameters are a production load, bottle weight filled 0.5 kilograms per bottle lies, production rate 6,000 bottles per hour, total load on belt is approximately equal to 500 kilograms of bottles on the belt at any moment. This gives the load mass entered into a Python program. B belt length. In medium-sized beer filling lines, conveyors between machines are typically belt length 10 to 15 meters. For our design example, we use belt length equals 12 meters. C. Belt speed. Beer production lines require smooth and synchronized movement. Typical belt speed 0.4 to 0.6 meters per second. For our design, we choose belt speed equals 0.5 meters per second. D. Friction coefficient. Food-grade plastic chain or PU belts on stainless steel rollers have low friction. Typical friction coefficient 0.02 to 0.04. We use a standard design value. Mi equals 0.03. E. Drive pulley diameter. Small to medium conveyors in beverage plants typically use drive pulley diameter 250 to 350 millimeter. We select pulley diameter equals 300 millimeter, 0.3 meters. Gearbox efficiency. Helical gear reducers used in conveyors have efficiency 88% to 95%. We use a realistic design value. Gearbox efficiency equals 90%, 0.9. Safety factor. Continuous production lines require reliable operation. Typical safety factor 1.3 to 1.5. We choose safety factor equals 1.5. H supply voltage and motor standard in industrial plants. Standard motor voltage 380 415 volts, 3-phase hours. Motor type, i.e., 3 high efficiency induction motor chain. This does not enter calculations, but is part of real industrial specification. Connecting engineering theory to Python. Let's see how Python uses them. In Python, we receive inputs using the input function. We convert inputs to numerical values using float. Each input is converted to float because engineering calculations require decimal numbers. Step-by-step Python logic. Our program follows these logical steps. Ask user for conveyor design inputs. Convert necessary units. Calculate friction force. Calculate torque at pulley. Calculate mechanical power. Apply gearbox efficiency. Apply safety factor. Display final motor power recommendation. Each step represents a real engineering calculation. Thus, Python acts as an automatic design engineer. Why automation matters in industry. In real factories, design engineers repeat these calculations many times for different projects. Manual calculation is slow, prone to human error, difficult to update data. Python automation provides instant recalculation, consistent accuracy, easy modification, reusable tools. This is exactly how modern engineering companies operate today. Today we learned how to determine forces in a conveyor belt, how to calculate torque and power, how gearbox efficiency affects motor size coming in, how safety factors protect equipment, how Python automates engineering design. This is a perfect example of mechanical engineering plus Python automation equals smart engineering. At this stage, we will input a fully prepared engineering prompt into the AI model. This prompt clearly defines all required parameters, formulas, and output formatting. The AI will then generate a complete Python code that automatically performs the conveyor motor sizing calculations for our project. In modern
It's
industry,
not only design a
engineers
machine,
do not
design
only
software,
design machines, they
design
design
machine.
software tools
This
that
Python
design machines.
turn
With
engineering
Python, you can
automatic
turn
design
engineering
program.
formulas into
Today,
automatic design
we
programs.
build motor
Today,
sizing.
we built a real
In
conveyor
the next
motor
lesson,
sizing tool.
we
In
will
the next
even more
lesson,
advanced
we will
AI
build even
automation
more
tools.
advanced industrial
Thank you for
automation
watching
tools.
to
Thank you for
RE07.
watching
Don't forget to
RE7
subscribe
channel.
and
Don't
comment.
forget to
See you
subscribe and comment.
next engineer.
See you in the next engineering automation lesson.